Okay, so we know y equals 4x minus x squared. This right here means our parabola is going down, correct? And this right here is we have a linear that's going up. So if I put those two together, it's going to look like this. So I'm going to put this one as, well, actually, let's highlight the top and the bottom first. So here's my top, and here's my bottom, and I want to find the area bounded by that. So what kind of line can I make so it's forever touching the pink and forever touching the blue? Horizontal or vertical line? Vertical? So if it is vertical, is that with respect to x or with respect to y? X, very good. So that means I need to make y by itself. And it looks like y is already by itself, right? So this one is going to be 4x minus x squared. This one down here is going to be 2x. So then we need to also find out what is the x value here and here for me to scan left to right. For that to happen, because it's the intersection, what do I do with these two equations? Set them equal. So I have, let's see, 2x is equal to 4x minus x squared. This part is the algebra 1 piece because really in the end we are factoring. To factor, we move everything on one side. So if I move the negative x squared, we get positive x squared. And I'm going to go ahead and put minus 4x is going to give me minus 2x is equal to 0. Any questions on how I got minus 2x? Okay. And then let's factor out the x. Then I have x minus 2. So that means the intersection of the x value is x equals 0 and what else? X equals 2. So this one's going to be at 0 and 2. So let's put our integral from 0 to 2. Top minus the bottom. Dx. And I want to go ahead and put these two together to make it shorter. So 4x minus 2x is 2x minus x squared dx. And we can all add 1 and divide it by that number. When I add 1 to this one, we get x squared over 2. The next one is going to give me x cubed over 1/3. Let's go ahead and cross this guy out. We don't even need that anymore. And our bounds are from 2 to 0. So at this point, all we have to do is plug it in. When I plug in 2 into this guy, we get what? What is 2 squared? 4. Minus, when I plug in the 2 into x cubed, it's going to give me 8 over 3. Do I really care about the 0? When I plug it in, it's going to be 0 anyways, right? So then let's go ahead and make our common denominator. 4 with the common denominator of 3 is going to give me 12. Minus 1/3. And that's going to give us 4/3, which is which answer? B. And these are the easier area under the curve, so please do not miss them. It might be tedious, okay? All right, let's go on to number 16. Sixteen is going to be the one, if you miss, maybe you might miss this just because we might get a brain fart. And actually, before we do 16, let's do number 17 because I might need extra room. I want to see how far I need on the 17. Okay, on number 17, Jacqueline, let's read.
Let G be the function given by g of x equals x to 3 t squared minus 5t minus 14t. What is the x coordinate of the point of inflection of the graph from G?
So for point of inflection, how many times do we need to derive? Ooh, let's see. When given a particle, point of inflections, we need to derive 3 times and set that equal to 0. Because the number between positive and negative must be 0, yes? Okay, so then we have, I need to derive this once, and I don't know why it's on the bottom. That's weird. Looks like G sub 1. Now here's the good news about this one. If I derive G, I get G prime, correct? But if I derive the integral and the derivative cancels each other out. So it's just going to be this statement right here. And I don't like t's, so I'm going to stick with the x's. If you like n's, use that, whatever you prefer. And then let's derive that piece. X squared derivative is 2x. Negative 5x derivative is
-5.
minus 5, and then we don't need to worry about the constant. Set this equal to 0. And hopefully you can just do this in your head. It's going to be move 5 over divided by 2, which is what?
5.
Boom. So I'm going to use all this room for number 16. If you want to make a little line to say, hey, this is number 16, go for it. And I'm going to write number 16 over here, so I'm not going back and forth and making you dizzy. And I'm thinking ahead, so I'm going to put the 1. Okay, Kylie, go ahead and read number 16 for me.
If dy over dx is equal to 2 minus y, and if y is equal to 1 when x equals to 1, then y equals.
So we have to go ahead and put the x's together and y's together. So y is over here. I'm going to put it together with this y and move the dx over. So when I do, I get integral 1 over 2 minus y dy is equal to integral of 1 dx. So I'm just positioning it so the x's and the y's are together. And I don't have any more x's, which is fine. And let's kind of recall u substitution. We're going to let the bottom be the u. So let's write that off to the side. U is equal to 2 minus y. So du is equal to what? Negative dy. And let's kind of match. I have 1, I have dy. Do I have negative? So let's kick that over. So let's go ahead and directly substitute. Let's move the negative outside of the integral. We have 1 over u du. And then let's integrate this one separately. What is the integral of 1? Just x. And then we're going to write plus c one time. Hopefully by now you know the integral of 1 over u. It is natural log of what kind of number?
Absolute value.
Very good. Absolute value of u is equal to x plus c. Now we need to go ahead and put the u back in. My u was 2 minus y. So we have negative natural log of 2 minus y equal to x plus c. So now let's see what other information is given to us for us to find the particular solution. They gave us when x equals 1, y equals what? Also 1? So let's plug that in to find what the c value is. So we have natural log of, if I plug in 1 in here, we get simply 1. Then we have 1 plus c. Something unique is going to happen. Absolute value of 1 is always what? What was that? 0? 0? Yeah? You're like, what? So we know c has to be what value? Negative 1. So then let's go on to this guy right here and rewrite it. We have negative of the natural log. Because I'm thinking ahead, I'm going to use parentheses because at some point natural log is going to go away. If you want to be safe and leave the absolute value, go for it. Okay, I want to get rid of the negative. So if I get rid of this negative, that's going to give me, everything's going to be opposite on the other side, minus x plus 1. So now let's do a pre-calc concept. What is understood base for all natural logs? E. Do y'all remember drop and cross? You might have also remembered somebody else used around the world. I don't use that. So when I drop and cross means I drop the E. I cross the other side as my power. Is equal to the argument goes on the other side. So you drop the E, cross the remaining. And y'all see now why I had parentheses around the natural log? Because it's going to go away anyways. So then if I were to solve for y, I'm going to move this y over, which becomes positive. I'm going to keep the 2 as it is, move all this by subtracting. Now let's look at your answer choice. Which one matches that? B it is. And yes, that was quite tedious. So here's the idea. For questions like number 16, you'll be saving a lot of time from the easier ones and pour it into this one. Good? Okay.